and a lot of the jobs and a lot of the efficiency and the performance is actually coming from. So we have always given in the previous green cars, green vehicles, and now to zero, a strong importance to these aspects, because it's, let's say, it's a part where we have a good performance in the market, for instance, even though we are sometimes a little bit behind in the vehicle level. I went to China, and in one company they presented their products, and then at some point they said, okay, this is the national model, and I didn't understand what they meant. Then I asked, and they said that this is with Chinese components, the rest is with European components. So I think that's an area where we are, you have to strongly concentrate to keep this know-how and improve it. And of course, make it the area where the jobs which are going to be reduced in an area where will be kept and increased in this area. At the same time, as I said, the performance is depending on them, and efficiency in particular. And efficiency then means a smaller battery or more range for the same battery, and so on and so forth. So also from that point of view, it's essential to keep investing into this level, and at the same time try to solve or reduce any issue that might emerge, and the effects we are witnessing now are clearly showing the need to try and be as independent as possible also from the raw material point of view. So we will see also, and we'll see even more in future calls, the stress, for instance, on reducing rare materials for cost, but also, as I say, for dependency. The Chinese, a few years ago, from one day to the other, just closed the export to Japan because of the Senkaku controversy. And of course, if we had something like this, if we depend only on permanent magnet motors, we might have an issue. So we have to have this holistic view, and I think that the projects we are going to see are giving us a flavor of the work being done on this. And as I said, also in future work programs, we will strive to keep this focus, and even in some cases make it more powerful, for instance, by considering more and more an LCA approach. So without further ado, now I see that the room is as full as it was before, let's say. So let's take that as a reference. So I will now introduce Professor Brandstetter with the Sys2Wheel project. He's has a long career in this domain, including automotive and electric motors and so on. And now he's leading this project, and he's also, let's say, well known in other bodies like ER, 3PS, and so on. So without further ado, I leave the floor.
So thank you very much, Maurizio Maggiore. Good morning, everybody. So I'm proud to present Sys2Wheel. So Sys2Wheel, as the name indicates, we tried to bring as much of the components as possible close to the wheels, so freeing space in the center of the vehicle. So we want to develop cost-efficient, scalable electric drivetrains for commercial vehicles, and that's why we are freeing space for the center and for additional cargo, or when we want to increase the range for additional space for the battery. We have some major developments here, an electric axle for an N2 type vehicle and in-wheel motors for N1 type vehicles. Efficiency goes, of course, with these components. but also very much with advanced control strategies, as you can imagine. I put here the website link where you find a lot of information, a lot of dissemination activities, a lot of material that is publicly available concerning these vehicles and the technologies. So please have a look at it, and we are also present at LinkedIn. So we got the funding as a small project. We got the funding of around 4.8 million euros from the European Commission. And this is our project in a nutshell. So where do we want to demonstrate our innovations, as mentioned, in one N1 type vehicle and in one N2 type vehicle? So you see on the left-hand side a bigger N2 type vehicle from Iveco. Right-hand side is a Fiat Doblo, a smaller vehicle. So we are focusing here really on commercial vehicles that are dedicated for last mile delivery. And this is where the field what we want to cover. This is the field what we want to cover also with mission profiles. And with mission profiles, there comes new control strategies, there come new testing methods, how to evaluate this vehicle and the performance of these vehicles. We have here as basic component supplying partners Elafe, TTTech, AVL for the motor design. Elafe is the same. We have for the Eaxle system FPT, and we also have some very innovative approach with a partner from Israel to free space in the cargo compartment by putting the dampers outside of the center position and putting the dampers close to the wheel. Unfortunately, due to COVID issues, we are suffering from a project prolongation. So actually, the project should have been finished end of last year. But we have a prolongation for 9 months, and the remaining 9 months will be used to put everything together and put everything on the test track and evaluate the performance that has been proven already by means of simulation. So the objectives of the project in a nutshell. So sorry for this strange identifiers. I will comment on these later. Reduce cost in mass production for commercial vehicles by at least 20%. And especially the motor manufacturers we had and the motor developers we had on board, AVL and Elafe, were very, very busy in reducing the cost of their electrical machines by reducing both motors are synchronous motors. Both motors use water cooling technologies, and we try to reduce rare earth content as much as possible. So 20% seems feasible, but also the cost reduction has been done by Elafe for their machine because they developed a dedicated production line for the motor they designed for the project to decrease cost in the production. So this was very, very helpful. Increase in powertrain efficiency, as mentioned, we get a little bit of increase that's coming from these components, but the vast majority of efficiency can be gained by efficient and advanced control. Weight reduction is one thing. We took in the demonstrator vehicles many components out, of course some components in. But in total, we got a weight reduction. The comprehensive affordability and user-friendliness, here we have to consider the special business cases for the commercial vehicles and for the logistic companies. So the business cases, of course, as much as possible cargo space and as little as possible stops due to recharging. So we, as System-Wheel, are part of a cluster of European projects where a couple of colleagues present their projects. It's called Evolve Cluster. Evolve Cluster has an own homepage where, especially for all the projects you see here on the list that are in this cluster, you find some dissemination material, you find newsletters, and quite interesting results. So going into detail of Sys2Wheel, so we are currently looking at the N1 category vehicle. So remember, this is the Fiat Doblo. The Fiat Doblo is equipped with an in-wheel system. So in the front, we have 2 in-wheel motors, and in the rear, this special damping system is placed, where we freed as much space as possible for additional battery. So red is new, coming from this project. Green is the current production of the vehicle, and here you see the damping system. Here you see the in-wheel motor. To the damping system, see a very odd-looking design, I would say, but this design has, of course, been tested on NVH issues, on vibration issues, on mechanical properties, and is considered safe for automotive production. So freeing the space in the center, and here you see additional space available for the battery where no cells or modules could be placed before this development was installed. Here again you see the in-wheel motor in front with additional battery space also here in the front, increasing of course the range. Here you see a snapshot of the in-wheel motor production line, a special designed machine where manufacturing is reduced to a minimum, and automated production of this e-motor is considered. The e-motors run with 400 volt DC, and they are roughly about 74 kilowatt power. So the vehicle is produced, assembled. So far we got in this project with all the innovations. Here in the rear you do not see actually the damping system, but what you see here is the in-wheel motors in front with additional space for the battery. A new cooling system has been done, also reducing weight to a certain extent. The inverter components also in the underhood have been developed by Elafe. And additional features of this vehicle is the improved thermal management, as I mentioned before, and a time-sensitive network. So a time-sensitive network, here especially we focused on communication in-wheel communication between components. And the time-sensitive network, of some of you might know, enables safe communication in the vehicle with existing lines, existing power lines, without having the need of putting additional communication cables into the vehicle. So freeing also space and reducing weight by reducing cables for communication purposes. Coming to the N2 type vehicle, so we are, the main innovation here is a fully modular Eaxle system, I would say. So here you see a sketch of the Eaxle, and this has been produced and currently integrated into an Iveco Daily. The main feature here is really the full modularity. So you can use the same design, of course, expanded in length and diameter, but the same design for different vehicle weights and vehicle sizes, reducing for several components really the production cost by having a standardized component box where you can feed many production lines for many vehicles with. So another feature is, you see, the Eaxle consists of 2 different motors that can be controlled and will be controlled separately. This means that this Eaxle can also, you can also realize some torque vectoring with this Eaxle. Question is if it's needed in inner city traffic, but anyway, it's possible. Here you see the motor of the Eaxle. So again, so some 72, 74, 73 kilowatt peak power machine. Yeah, and runs also on 400 volt DC with an inverter in between, of course. So mid to long-term expected impact. So yes, these are, of course, the impacts that are required in the call text of the GB01 call, and which we meet, of course. But the more interesting thing is what happens also as some kind of side effect. Of course, we have this from Elafa, the Inwheel motors, and the market uptake here. The increase of number sold motors. So Elafa is very started already to produce this type of machine and try to integrate it in other vehicles as well. The same for Elafa, but for AVL, but the motors is a completely new development, and this has to be tested, and there have been some issues due to COVID-19, so the tests are still lacking. For FPT side, the Eaxle system, you remember this fully scalable Eaxle system. This is foreseen to be put on the market end of this year, beginning of next year. Iveco, of course, the zero emission vehicle for last mile delivery is a selling proposition. And interestingly enough, we have a very small SME on board, Habitronics. They put here for this N1 type vehicle an energy harvesting device in the wheel, harvesting rotational energy and supplying sensors. So it turned out during some advisory board meetings that this could be very useful for as an additional business for logistic companies selling data that are collected in the wheel from road wheel contact. And of course, TT Tech Auto is already about to sell their TSN, the time-sensitive network approaches. So thank you very much for your attention, and open to your questions.
Thank you very much. And we move now to the project EVC 1000, which is looking at again components for achieving these performance targets in the call. The speaker is Dr. Armango. He's also been for a long time in the automotive industry, and is currently innovation manager at AVL, and has been coordinating several projects in this domain. So, thank you for being here, and the floor is yours.
Thank you very much. Thank you very much, Maurizio, for this very kind introduction. So here my target for today, so I have 2 targets, honestly speaking. The first one is for sure to present so the EVC 1000. And the second one, to my opinion, even more important, to engage with you. What does it mean? What does it mean? So here we claim to have developed new solutions, new product, new engineering services, new solution in general, which are so relevant for the market. And this, so we have now an audience of a lot of experts, and this will be very interesting for me to get this feedback. Yes, did we achieve this target or no? So how to improve? So it means where our component, our proposed component, could be used in your solution, respectively, which kind of technology do you have that could support us to further improve the outcome of our project. So here my target is really engagement with you, really looking forward to distribute some of my visit cards to continue this discussion bilaterally with you. Okay, EVC 1000, electric vehicle component for 1,000 kilometer daily trip, a consortium of 10 partners. Similarly to Bernard and to Sister Wheel, our project has been extended by 6 months. We will complete, we will successfully complete the project by end of June. Yeah, and as you can see here, in terms of partners, a good mix between car manufacturer, component providers, engineering providers, scientific partners, in order to have the full value creation chain within the project. So EVC 1000, the target of the project, the target of the call was to improve the component. For that, our philosophy was to say we need to improve the powertrain related as a component. You will see in-wheel motor, you will see inverter, and to combine the powertrain and the chassis component, stating that we need first smart, innovative new component, and second, we need an intelligent, market-tailored integration of this component into vehicles. And for this target, we have 2 target vehicles, 2 targeted markets, with Audi and GAC, here. So in terms of results, as we have seen before, in-wheel motor with a target to provide higher performance directly in the corner, to provide corner solution for electromobility. Electric wheel dual drive with a target to have a better, more accurate and synchronous control of the motors. We will have as well a brake-by-wire component, in order to have here more flexibility in terms of braking, and very similarly electro-hydraulic suspension, stating that for customer acceptance of electromobility, then we need to improve range, we need to reduce the cost of the battery, and we need to take into account as well comfort, drivability aspect. And this is here the target to provide different kind of components for the powertrain, for the chassis, providing all of them higher degree of flexibility, and to have here a more advanced and more integrated control strategy at vehicle level. So here to optimize locally the efficiency of the single component, and to optimize globally at vehicle level, operation for a specific market, for a specific specific target, vehicle target. Moving to the results. Here we are in the phase to finalize a vehicle demonstration. You will have in this picture, real picture. This is ongoing work. On the Audi vehicle, where you can see on the left part front corner with the brake system and the damper system, with Brembo and Tenneco. On the rear axle, the dual inverter mounted in the from Ideal Motion, and on the rear corner, in-wheel motor, damper system, EMB caliper as well. Here we are on the phase to finalize vehicle demonstrators. We are on the phase of going for an homologation in order to be in the position to make a 1,000 kilometer drive on public road, and showcase that these components are sufficiently mature for a later exploitation, and are in the position really to achieve the targeted the targeted project objective at the end of the day. Results. Very similarly, Bernard, we have already aligned our project, and we are aligning our pitch as well. We are already at the very start of the project. Preliminarily validated our target by means of a simulation. During our component development, we could then validate the component-specific objectives, and for the remaining 3 months, we will hopefully validate these targeted objective on a real vehicle. We'll have here 2 vehicles in order to address these topics. Collaboration, and I'm really happy to be there today, and I'm really happy to was there yesterday because some of the projects we are referring to were presented already so yesterday or are presented currently so today. So here first active collaboration with related project initiatives. So here focusing strongly on the Evolve cluster, so that we can really exchange with sister project, I would say, increase impact creation through this collaboration, exchange on specific technological aspects. You have seen that in Sys2Wheel, for example, partner Elafe was there to provide and further enhance their Inwheel motor solution for commercial vehicles. So here we have Elafe further on in order to improve and tailor their technology for passenger car. So this kind of collaboration has been enabled and strongly supported by the Evolve cluster in this context. I would like to mention especially operative collaboration with the Eaxle for EV project, and this is an error from my side from the from a Vision XCV project as well, should be here as a second part. Rainer, please accept my apologize for that. So here this was very interesting to have this tight collaboration with the GV02 project, providing here innovative methods for the development, respectively, for the validation of EV component. This was a possibility for us to accelerate our development and validation through innovative methods, with the direct participation of different partners present in this project. In terms of follow-up, here we are very honored that we were in the position to set up already different follow-ups, mentioning in this specific case HiScape and HYPE project, which has been recently granted. So here really happy to see that these topics are of high relevance and will have then follow-up in this aspect. In terms of impact, here maybe on the right side, as mentioned at the very beginning, our target was to showcase how far these new components are scalable in terms of targeted market. And this was with the usage of 2 vehicles. So we have the possibility to address the user-friendly, affordable EV market, with a GAC vehicle, and the high-performance EV market with the Audi vehicle. So here, showcasing that these components are suitable and customizable for different kind of markets. Following and the last slide from my side, so here the different question in terms of impact 2030, so future research needs. So to our opinion, the topics of technology convergence is a very important aspect. So here, in order to provide innovative components which are then integrated for mission-specific activity. So this is a very important aspect. So here, the convergence toward connected automated mobility, the convergence toward a smart mobility and really tailored road application. Expected market uptake for technologies and solution developed in our project. So here we have a different stage of maturity. So we have a component on one side which have already a high degree of maturity and where this component will be soon available on the market. We have other partners, especially car manufacturers, who were very interested to explore the technology in order to have a sound basis to make a strategical decision how far to move towards this technology or what is here appropriate timeline to make this transition. So here, different maturity in terms of technology, but high interest, high commitment from all the partners. Consortium plan to ensure follow-up of project activity, already mentioned different follow-up, a project already granted, and I'm really happy and proud to say that we have already bilateral collaboration that rised up out of this activity. So here the partners are interested to further collaborate together in a more bilateral aspect. So here, to my opinion, very strong success as well in this aspect. How can other projects benefit from your activity? And this is now the reason why I'm there, and this is the reason, hopefully, why you are there. So here, this is about engagement. this is a better engagement, and I hope now, so through these last few minutes, that I can convince you to come to me and say, hey, great ideas, how can we use that for our project? Or, hey, I have a perfect technology or a perfect methodology. How can I push this technology to your project, to your partners? And this is here my kind invitation. I have so few business cards. I would like to get rid of it and really looking forward for the discussion with you. Yes, so then at this point in time, so thank you very much. Thank you very much for this opportunity to present the project today. Thank you very much for your attention and looking forward for a lot of questions and very fruitful discussion.
Thank you very much for your presentation. And we move now to the next project, which is looking to something slightly different. The project is looking at components and architectures for lower, let's say, voltage than usual. So I would call Dr. Pietro Perlo, who from a long experience at the research center of Fiat, has moved on his own little company called IFEVs, which is trying to bring these vehicles, small vehicles, light vehicles, to the market. So the project TEL is the next one.
Thank you, Maurizio. To you. Ladies and gentlemen, friends, I have the pleasure to introduce you to this exciting project, I would say, which involves Infineon as a coordinator, Valeo, IFEVs, Dana, and the University of Surrey. I'm trying to respond to the questions of the organizers. So, where are you going? Also, with respect with the market, what is your perspective? Now, the objective of the project was to develop efficient powertrain working at 100 volt and 48 volt in these M1 and N1 urban electric vehicles. And we are targeting 3 sectors: small to medium segments electric car, mild hybrid, that was the first target, but things change at low voltage, and lightweight urban mobility. So let me start with the development, which I consider the state of the art in the world today at 100 volt. Now, many are developing very efficient motors, but here it took me years to convince Dana not to think so much about the peak efficiency, but think about the efficiency at the low RPM, because this is where the efficiency in urban drive really matters. And have a look at the vertical efficiency you have at low RPM. This is really unique. It took many years to Dana to come to that point, and this is possible only if you have silicon MOSFETs. Okay, and Infineon here is really doing very, very, very nice work in terms of MOSFET, but Dana took years. And after they had these results, the paradox is that Dana was an Italian, a small company, Italian company. They presented this to an American company, and the American company, Dana, purchased immediately because that was the state of the art in the world and remains. And this is also for the inverter, okay, not just for the motor. So I'm going fast now. Going fast because I want to introduce you to the movies that we have also on crash test. So these are the 2 installations. On the left, we have the 100 volt with the differential. On the right, we have the first result of the project. Dana and Valeo have collaborated to also integrate the differential, because Valeo didn't have any development on the differential or reducer, if you want, but Dana has. And so that was the first result. They merged their activity, and they came to also a solution with the 48 volt, a very nice solution, with the belt, by the way, and also very, very, very efficient. So these are the 2 installations in the rear axle. We only have 4-wheel drive in our technology. Okay? So all our vehicles are 4-wheel drive. Okay. So now let's see in terms of speed. I'm going fast, okay? In terms of speed, at 100 volt, we tested the vehicle at 150 kilometers per hour, okay? But we limit everything at 120. At 48 volt, the top speed that we reached was around 110, but we limit the vehicles at 90 kilometers per hour, okay? So this is what we are doing. Tests are available. We made many tests in this direction. Now, what about energy consumption? In the 100 volt, we have about, we first personally like very much to know what is the energy consumption at the constant speed before talking about the urban drive and various technologies. I like always having an idea what happens at the constant speed. And you see that at constant speed of 30 kilometers per hour in the 100 volt, we have some 45 watt hour per kilometer at 52, 53 watt hour per kilometer. In the 48 volt, the energy consumption is a little bit higher because, of course, the voltage is lower, the current is higher, and then you have higher losses in this direction. Now, what about the acceleration? The acceleration at the 0-50 is in the 100 volt. These are measured value, okay? This is not simulation. I just want to specify this. It's less than 3 seconds with the 48 volt. Four-wheel drive, always four-wheel drive. We are in the 5 or so seconds, which is acceptable anyway. I have to say that we are four-wheel drive, but specifically in the 100 volt, we do not have the same ratio front and rear. We have two different ratios, 1:9 in the front, 1:6:4 in the rear. Why two different ratios? Because if you have the same ratio, 1:9, you increase the acceleration at 0-50. But if you go to a lower ratio, you facilitate the higher speed in a shorter time. So we decided to have two different ratios, not just for four-wheel drive, but two different ratios. And of course, okay, and this is new, by the way. We didn't copy from anybody. In summary, the 100 volt, 0-50 in 3 seconds, 0-100 in 12 seconds. At constant speed, 45 watt hour per kilometer at 30 kilometers, 52 watt hour per kilometer, per kilometer, not 100. It was kilowatt, sorry, I made a mistake, okay. I canceled this morning, sorry. But people want also to know what is the average consumption in the VLTC cycle, and we are in the 10 kilowatt hour per every 100 kilometers. So it's also in terms of energy consumption, I would say, quite good. I'm not going to spend time on the vehicle control because yesterday Professor Sorgnotti already explained with many details how we controlled the torque in the two axles to let's say manage the vehicle in every wet road, icy road, or soaped road as we did. So the control of the vehicle is really fantastic because the University of Surrey, from this point of view, is really I would say in Europe, if not the best, very close to the best. But now I want to talk on what we did for the part that requires the investment, because people are talking about batteries and motors, but the real investment on making a car is not in the motor, in the battery, it's in the chassis. Okay, so we spent a lot of time in the years, thanks to the European Commission, to develop a body frame that was requiring very low investment. And if you compare the classical body frame with ours, we do not explain how we make the battery envelope, because this is still very confidential and it has a lot of know-how inside to reduce investment. And we are state-of-the-art from this point of view. And in fact, ArcelorMittal has asked us to, another result of the project, to use our solution for the battery envelope for their customers. this is not non-secondary aspect. No investment against the many millions that people have on making envelopes of the battery for the battery. So now we made crash test, okay? To make crash test, people that are in the automotive world understand that it takes many millions to make physical crash test, okay? Of course, we are a small entity, but thanks to the fact that we are collaborating with the CIDAUT, Javier is here, we made all physical crash tests, but the cars that we develop for the crash test use doors that are produced in a production line for us and only for us. So we have a pilot making these doors, and these doors is another result because Magneto Automotive, producing the doors for us now, is also delivering the doors to others. Because the investment to make this door only steel, we are the specialist on steel, as you will see later on, okay? Only steel requires from 15 to 20% of the usual investment on making doors and steel. And that's why people, because today the upfront investment is what really matters in the automotive world, more than yesterday. So this is real production. The windshield are real production made by us, okay? By Pilkington, only for us. And then the bumpers and everything is, we only left some spaces to understand during the crash what was really happening in the absorption area, okay? But we needed to make many vehicles of this in a project, okay? In a single project. So let's see what, oh, sorry, excuse me. I have to launch the 2-minute video of all physical crash tests, proving that these are state-of-the-art results for this type of vehicles. No speculation, these are real, okay? And also, CIDAUT is a specialist on this. You see, these are real vehicles developed, but you will see now the physical crash test performed by CIDAUT. CIDAUT did indeed a very nice work also to support us in the simulation. These are the classical tests for the full frontal, lateral crash test, the off-axis. So this is the real test, okay? And these are the results. You see that the result is lower than 40G, which is 15G less than what you have in city cars today in Europe, 15G less. This is the off-axis, and you see the performance, the off-axis. First of all, no breakage of the windshield. You see that all biological parameters are lower than what the regulation is asking. You see the lateral crash test here also, and also the parameter, the lateral crash test are very good, I would say state-of-the-art for this type of vehicles, certified by, of course, by CIDAUT, which is a specialist in this. Then we still do not have the real field, but we made the simulation. We understand that we are very close to what the regulation is asking for the pole test as well. One vehicle is still there to finalize this aspect because the project is finished, but we are continuing in another project, Multimobi, to comply with this. Then we did various torsional and bending tests, 1 million cycle here to test the body frame because we want to make safety first of all, and I can confirm that also the results here are very good because there is no cracks, no deformation in the body frame after 1 million cycles, as the regulation is asking. So I would say that we have finished this part of the presentation. I can close here to say some seconds, okay, and continue with the presentation, I hope. Yes. So now the real vehicles are really there. We have the same body frame for all cars, whether it is a pickup or a passenger or a van. The body frame is the same. We are continuing now looking at with the Multimobi at a new approach towards autonomous without LiDARs and without radars, but using gimbals, infrared and visible, and we are coming to that point. But what it is also important as a fallout of the project is we are specialists in steel. And we say we want to develop bikes, because bikes is the game coming, okay? And we use the same technology that we used for the body frame to produce bikes using only super high-strength steel, tubular and metal sheets, as you see on the bottom. We have 20 patents just on this, 20 patents. And from next week, we will start selling bikes. And these bikes we will pre-sale. But in June, we will come in we have been invited by the European Commission to make, let's say, a roadshow at the Bauhaus Festival. And now I want to provoke you with 2 slides. Look at what's going on in the bike market. If you look at 2022, 2030, you see that there will be a need of 100 million e-bike in Europe. By the way, per every electric vehicle sold today in Europe, there are 6 e-bikes sold. And the number of kilometers run by e-bike is 30% more than the number of kilometers run by cars. Official statistic today in Europe, okay? So we need 100 million e-bike by 2030. This is a fact, this is a conservative projection of CONEBI and all cycling association. Conservative, I close. And now, the most impressive slide. Have a look at Italy, Germany, France, Spain, almost all the same, okay? Today, we have 650 cars per 1,000 people altogether, okay? And in 2030, the number of cars per 1,000 people will decrease. This is a positive point of view, because the negative is, I'll say, much less than that, okay? But the number of EV will not replace the number of IC, of internal combustion engine. This is taken for granted by almost everybody. But look at what's going on for the bikes. Today we have 50 bikes, e-bikes, per every 1,000 people. If you look at the projection that I showed before, in 2030 in Italy, we will have 650 e-bikes per 1,000 people. Whether you like it or not, this will happen. This is a conservative projection. It is not a speculative one. So the bike world is exploding. And that's that. I thank you, everybody, for the courtesy. The last one is, could you do this work without the European Commission? No, sorry. Without the European Commission, we could do nothing of this. The European Commission is the most serious environment where you can apply and compete. Big thank you to the European Commission and to all of you for the patience of listening.
Thank you too, and thank you for the thank you. I'm giving now the word to the High Ecobot project, who's looking at another aspect, which is heat exchangers. We will have Michele Arinda presenting it from CIDETEC. He's the technical coordinator of the project. Please.
Thank you. Okay. So as the Jacoba project is focused on intelligent heating and cooling solution for enhanced range electric vehicle parks. So we have seen different improvements, but this is focused only in the heat exchanger and the thermal system. So Ecobot project started the 1st of January of 2019, and it will end this year, the 13th of June. And just to mention that we are a small consortium of 6 partners, where as CIDETEC Energy Storage is coordinating the consortium, and where we have Audi, MIBA, another research center that is CEA, Lumartov and DATIC. Okay, this project has 5 main objectives. The first is increase the powertrain overall efficiency up to 5%. The second one will be reduce the total cost of the whole thermal system at least 20%. The third will be to integrate new components and functionalities. This will be the smartness of the project, leading to higher user-friendliness, reduction of range anxiety, and temperature impact on the degradation of the battery pack. Then the fourth will be to achieve automotive class quality, which we have achieved thanks to Audi being involved in all the work packages. And then generate some demonstrations to demonstrate the efficiency, increase and addition of new functionalities in the vehicle. In this case, what we have done is a prototype of the heat exchanger assembled in a battery pack, and it has been tested at lab level. And then we have developed a B-sample, an industrialized version of that prototype in a virtual way. More or less, you can find here the workflow of all the project, but what it is important is the result of the project. We have 3 months to finish the whole project, and we have already gotten some values of the KPIs and some results. The first one is that we have been able to design, manufacture a heat exchanger based on Miva's flex cooler technology. Here there are some examples that you can find in Miva's webpage. And this has been assembled in an Audi e-tron battery pack. Additionally, on the design heat exchanger, we have printed thermal sensors and heaters, heating actuators, which simplifies a lot of the assembly process of the whole battery pack. And here we have some values of where some of them are not completely quantified, but I wanted to highlight some values, such as we have reduced 22 kilograms of the whole battery pack, and also that we are able to provide more energy, so we heat more the batteries, while requiring less cooling power from the thermal system. And this is representative, it shows how the new heat exchanger has higher heat transmission capability. And then in terms of cost, there is a problem in this case, because it's not simple. It is not direct, the changes we have done into the thermal system and the sub-objectives we had. We have seen that the main cost reduction, almost 99% of the quantified one, comes from the removal of gap filler between heat exchanger and battery pack. And that, in this case, the simple heat exchanger design with less complexity was around 1% of this 60, the reduction of 60% on the cost. Then another result of the project has been the work done by the both research centers from CEA and CDTech regarding to the modeling of the battery heat exchangers and the battery pack itself. We developed a modeling library in MATLAB Simulink that reduced thanks to the SFD simulations, we reduced considerably the computational cost of the modeling. Then we develop also to address all the smartness and all those additional value to the project a smart controller that it will be presented on a conference in May and will be proceeding published in a journal. And then we have also parallelly we developed and validate the concept of a machine learning based controller that is available in MDPI Energies. And if you want, these results are public, so you can check them and use for your projects, of course. Another result is the software tool for external diagnosis and safety and secure data cloud management that was developed mainly by Datic. And we can find here the interface of the software as well as the tablet where this software was installed. This will make the bridge between the vehicle and the user. The user will be, or even the OEM will be able to observe in real time what is happening in that battery pack. And as well, they integrated via Simulink blocks the developed thermal control strategy. And in this slide, I wanted to focus on two aspects. One is the homogeneous thermal map and avoidance of non-desired thermal operation scenarios, where, thanks to the hardware itself, the developed heat exchanger itself, we were able to obtain a 30% less temperature dispersion between modules and cells, which is something with the prototype. And then that we were able to get a relevant reduction on the carbon footprint impact, human health impact, ecosystem diversity impact, and resources availability impact. Then what we did is the virtual B-sample. There is, I'm sorry, because there is an update version of this presentation, but I know the numbers, so it's okay. So what we did is we assembled physically the prototype, and due to the limited time we had, what we did is virtually develop the industrial version of that prototype. We took all the results from the testing of the prototype. Based on those results, we redesigned that prototype, and we, based on CFD simulations, we give some expectations of which will be the improvements of the new design. And in terms of cost, it will be the same, but there will be an increase of 5% due to the industrialization of that system. So we should add to this 65% more in the reduction of the cost. In terms of the overall power efficiency, we expect it to have a slightly worse because of the industrialized version was focused to reduce this from 30 to 50%, the temperature dispersion, which we validated through the CFD simulations. But this less dispersion bring us a slightly higher mean temperature. So it means that we will require a slightly higher power refrigeration energy. But we were able to have a more homogeneous temperature spread, and we were able also to decrease these values where they went from 5 to 10% lower. And just to finish with the results, The project has been already, is in the end of, we are in the end of the project. It ends in June. And just to mention that we have electric vehicle workshop that in the 17th and 18th of May that will be placed in Valencia. It will be an hybrid event. You will be able to assist there physically, or you will be able to assist remotely. And just to mention that the first day will focus on gathering all the key stakeholders and the projects related with green vehicle, and that the second day will focus on the innovations done at component level. And you are all welcome to the workshop. And in mid to long-term expected impact, just mention that what it lacks, what it is pending, is bring birth to that industrialization, to industrialize the project, and add this industrialization into the OEM fabrication manufacturing line, and also, but finally, pass all the homologations and in a real vehicle. But the concept is already validated, so that will be the last steps. And just mention that the developed technology is cost bursting. There is a significant reduction on cost, and also it provides higher efficiencies, which it's quite interesting for the market. And what is the contribution in general? Okay, in general for the Green Deal, smart and sustainable mobility strategy, etc. But it will be, I will say, that will affect the affordability of the electric vehicle, since there is a significant reduction of cost, and this anxiety and safety, rains anxiety and safety, this public concern about the vehicles could be improved, since we will improve we will reduce the energy consumption, and also we will be able to, thanks to that smartness, we will be able to operate in some ways that even the demonstrator, the software, that user friendliness will help in these all concerns. And just to finish, this project could be an initial start point for a new Coming Horizon Europe proposal in 2022. And just to mention that all the work done by CEA and us in terms of modeling and control strategy is public, so it can be used in any other project, and that we think that we have gained at least 1.5 years if this project wouldn't have happened. And this is all. Thanks for your attention.
Thank you. Perfectly on time. So we have the last intervention of the session, which is the FIDGEN project. And the project is looking also to an integrated Eaxle, so like one of the previous ones. And to present it, we have here Dr. Michele Di Gennaro from AIT, who has been working in many projects in automotive, but now looks like he's getting back to his aerospace background in the electric arc technology research at the Austrian Institute of Technology. So please, the floor is yours.
Thank you, Maurizio, for this kind introduction, and good morning, everyone, ladies and gentlemen. Thanks to be here to my presentation of FIDGEN. FIDGEN stands for Functionally Integrated Eaxle, Ready for Mass Market Third Generation Electric Vehicles. And the objective of the project, in a nutshell, is to extract the maximum performance from an Eaxle, staying within the boundary of production cost of 2,000 euro. So we want to extract, we want to deliver the most performant Eaxle possible within this cost boundary, and in a way that is as multi-platform as possible. The project is carried out by a consortium of 8 partners from 5 member states and 1 associated country, Switzerland. I would like to mention here all the partners: AT, which covers the role of the coordinator. We also design the cooling system of the Eaxle, and we do test at the bench the Eaxle, qualifying the performance. CRF, which is in charge of providing the project with technical specification for the light-duty vehicle market and integrating the Eaxle and demonstrating the Eaxle on a Fiat 500 electric platform. Tecnalia, in charge of delivering the control of the Eaxle. Brusa, in charge of delivering the inverter motor design and prototypes. The Polytechnic of Torino, in charge of the recharging system and supporting the control delivery. ST Micro, in charge of delivering the silicon carbide power modules for the inverter, GKN for the transmission, and VUB for the eco design and LCA. The project was initially intended to last for 36 months, but as many projects presented today, has had some delays due to COVID and also due to some delays in the supply chain that we know that today it's quite a problem to get semiconductors and to get parts. It will finish in September of this year, and as an overall budget of 5.8 million for 5 million funding in an innovation action framework. The project was designed in 2018 to respond in full to the challenges of the GV1 2018 call, and again, its high-level objectives are to deliver a highly integrated Eaxle, which is natively brand independent and multi-platform, and advancing the state-of-the-art in different technological area, delivering different technological bricks. We were aiming at the proposal preparation level to increase by 40% the gravimetric energy density, the gravimetric power density of the motor, achieving at least 5 kilowatt a kilogram, increasing by 50% the speed of the motor, achieving at least 18,000 RPM max speed, increasing by 50% the volumetric power density of the inverter, achieving beyond 25 kilowatt a liter, and having 96.5% of motor peak efficiency, 99% of inverter peak efficiency, and of course, functional and physical integration of the different components. The Eaxle is planned to be demonstrated at TRL 7 on a vehicle platform that I already mentioned, the Fiat 500e, most likely the next generation Fiat 500e, and enable a driving range of approximately 1,000 kilometers per day, including 3 stops for recharging of 25 minutes each. So overall, we want to simulate a kind of 1,000 kilometer daily trip, stopping 3 times for recharging the battery, 25 minutes per each stop, matching a cost target of 2,000 euro a unit at mass scale production. The overall FIGEN concept is summarized in this slide. This is the Eaxle architecture. The very core of the Eaxle architecture is the internal permanent magnet machine, which is an 800-volt machine, 6-phase, which is connected downstream with quite a simple transmission. This is a direct single-stage transmission, and upstream to a 6-phase inverter, silicon carbide, state-of-the-art 800-volt inverter. The inverter is fed by the battery, but there is an extra element between the battery and the inverter, which is a bidirectional DC-DC. The DC-DC aims at stepping up the voltage of the battery from 400 to 800 to feed the 800-volt powertrain, but also to work for enabling super fast charge, so accepting 800 volt to recharge the 400-volt battery. The overall design of the FIGEN Eaxle is also fit to be coupled with an 800-volt battery by removing the DC-DC, which makes the overall architecture quite flexible and ready for different application in different platforms. This is the FIGEN implementation plan. Beyond the definition of the detail of the electrical architecture of the Eaxle, the project is built around three main technological work packages, what you see here as a core, WP2, WP3, and WP4, each of which aims at delivering a technology brick of the Eaxle itself. The area 1 tackles the power electronics, so delivering the silicon carbide inverter, the DC-DC converter, and the fast charging enabler. The area 2, which is all about the motor, delivering the high-speed permanent magnet electric motor and the transmission. And the area 3, which is devoted to the design of the cooling circuit and design of the control algorithm. Everything converges into WP5, which is about prototyping of the components, assembling of the Eaxle, and testing and qualification of the Eaxle on the bench at TRL 6, to step up in WP6, where we have the vehicle integration and the demonstration of the Eaxle at TRL 7. On top of that, we have, as usual, exploitation, dissemination, communication, and project management. We stand today here. We are at the end of WP5. We are in these weeks completing the test of the Eaxle in our laboratory, in our drive laboratory, and we will be ready in April to ship everything to Torino for final vehicle integration and vehicle demonstration. Some snapshot on the results of FIGEN. One main part of FIGEN is about motor. That's really the core area. What you see on the slide is a rendering, a CAD rendering of the Eaxle, where we don't see just the motor, we also see the inverter box and the transmission and some mechanical elements connecting the driving shaft, the stub shaft with wheels. The motor is based on synchronous approach with a patented rotor shape and delivers very high performance and very low torque ripple. It's equipped with 1.3 kilogram of rare earth-based magnets and with a patented formed Litz wire winding technologies for reducing losses. We were able to achieve at the bench 23,000 RPM, which is quite beyond state of the art as per today, of max speed. And we were also conducting at the bench a sustained overspeed test, sustaining 27.6 thousand RPM for 30 seconds without having any mechanical failure into the Eaxle. The motor standalone is capable of delivering up to 6 kilowatt a kilogram, pushing the envelope at 800 volt VDC, and it's coupled again with a single speed transmission with a reduction ratio of 12.5 to 1. The e-motor standalone efficiency measured at the bench is 97.4%. Moving to the inverter, which was quite another area where we did invest many resources. The design of the inverter is completely brand new. It's based on a cascade architecture. We have two three-phase inverter connected in sequence with surface-mounted devices implementing the next generation silicon carbide switches from STMicro. We have an housing volume of 5 liters, and we were able to deliver 35 kilowatt liter peak, also at 800 volt VDC. Here you see an exploded view of the design of the inverter with all the components inside. Some pictures coming from the different phase of prototypings of the different components. On the left part of the slide, you see the first prototype of the motor. You don't see too much, you just see the housing. We are not allowed to show the inner part. And in this picture, the first testing of the e-motor in a back-to-back configuration. This test was done at the motor manufacturer before delivering the motor to us for final qualification of the performance. In the mid-picture, there are some different part of the prototyping and end-of-line test of the boards of the inverter, and some picture also from the transmission, also test before delivering in a back-to-back configuration. And finally, the overall FIGEN Eaxle in the full assembly. This is the first of the two prototypes which we have delivered. We have two working prototypes. Duplicating is always increasing the reliability. It's a risk mitigation measure. And what comes next is the implementation into the Fiat 500e of the Figen Eaxle. Here you see a CAD rendering of what we are doing. We are implementing the Eaxle on the rear axle, so going back to the classic 500 configuration. And we have the inverter motor transmission group in between the wheels and the DC-DC on top. The DC-DC that you see here, that is basically this red box, is basically at the level of the trunk. So we're basically freeing all the space in front and on the back of the vehicle for enhance the usability of the vehicle itself. Some pictures also from the experimental phase. These have been taken into the AT Drive Lab, where we are testing and qualifying the Eaxle. So here you see the motor connected to our brake machine and connected to oscilloscope and a series of cables that my technician put in the lab to qualify the Eaxle in different configuration, and some results about the testing. These are testing at TRL 6 on our bench. The Eaxle was capable, of course, of delivering the full WLTP driving cycle, and we were measuring quite some very good values of efficiency, distance, specific energy consumption, and torque and current ripples. We have over the WLTC below 1% of torque ripple against a 3% industry standard. So this is quite smooth operation of the Eaxle itself, and below 5% of current ripple. On top of this, the Eaxle is quite energy efficient. We don't have yet the final number because we are repeating many measurements. But we measured in the first phase of the test 127 battery to wheel watt-hour per kilometer, which is quite beyond what is delivered today by the best-in-class market available technology. The energy efficiency of the Eaxle is also confirmed by the thermal envelope of the Eaxle itself. We see that the Eaxle stay quite cool. I must say that on the first test, my technician thought that the thermocouples were broken because basically the motor was not warming up. Over the full WLTC cycle, we see that basically the inverter stays almost at room temperature, plus minus 1 degree, so it does not warm up at all. And we can see a peak temperature of the motor of 37 degree in the phase 4 of the WLTC, which is quite excellent. This also is highly suggestive that we can push further this technology to the thermal envelope, and we can extract even more performance of what we have done so far. Some conclusion and some mid to long term expected impact of the project. Again, we were able to extract up to 6 kilowatt a kilogram against an initial target of 5 kilowatt a kilogram. So we were quite happy on that. Materializing a plus 70% improvement compared to the state-of-the-art 2018, that was the reference of the project, and a good 40 to 50% compared to the state-of-the-art 2022. What I'm doing now towards the final part of the project is also comparing Figen against the best-in-class technology today, not when the project was granted. We were demonstrating 23,000 RPM, so beyond the target of 18,000, which is a 28% more of the best-in-class market-available technology as per today, and 35 kilowatt-liter of power density of the inverter. One side benefit that was not initially planned for Figen is the reduction of the weight of the magnets. Thanks to the design and to the high-speed operation of the motor, we were able to reduce the magnet weight of 40% compared to the state-of-the-art 2022, where state-of-the-art 2022 is basically the average between Tesla 3 and Volkswagen ID3. We were not performing research on the magnets, so we were not aiming at reducing the percentage content of rare earths, but we were reducing the weight of the magnets, so intrinsically we were reducing also the content of rare earths overall in the motor. So, concluding, Figen is at the present one of the most performance-dense prototypes of Eaxle in Europe, to my knowledge, and it's an excellent technological basis for advancing further this technology. And I'm also thinking to what Figen did not do. Figen did not perform any work on the magnets, was just relying on the best-in-class technology available for purchase. So pushing in that direction would even further improve the overall design, as well as FIGEN, although complemented by an eco design and an LCA, did not do a full recycling demonstration. And this is something that it's also on the roadmap for developing after the project. Thank you for your attention. I would be pleased if you want to get in contact with us or visit our website at www.figen-project.eu. My name is Michele, and again, I give back the stage to Maurizio and Christoph. Thank you for being here today.
Thank you. I think now it's up to my co-chair, Christoph, to lead the question and answer. That having so many projects, I think, will be quite lively.
Yes. Okay.
You want to do it here? Or?
Yeah, I'll go to the podium. And get some little release. Yes, I think you're gonna go down, page down. Here we are. Good. Yeah, so maybe I can leave the mic here because there's the mic. So it's ready for the answers. So yeah, good, still morning. So yeah, and thanks for Maurizio for moderating the different presentations, and thanks to the speakers for their interesting presentations that we heard them this morning. So I think it's mostly, all these calls or projects were related to the 2018 calls, GV1 and GV2. And so just to start with something, so one question that I remember from the different calls was also the reduction of rare earth or rare earth magnets in your proposals. So Michele, I remember that you mentioned something like having 40% less magnets, and you did not customize, but the others, did you take any efforts in reducing the rare earth content in the magnets? So, yeah, you're on.
Not in FIGEN. There was another call, the GV4 2017, where reducing the content of rare earths in magnets for electric motor was
Yeah, it's working.
It's working, okay. Was a topic. Again, in FIGEN, giving the design of FIGEN and the high speed that we were able to achieve, even beyond the initial target, we were able to reduce the magnet weight. And intrinsically, we are reducing rare earths. But we did not work on reducing the percentage of rare earths per kilogram of magnets. And that would be the next line to develop.
Okay, thank you. Eric?
Yes, so for AVC 1000, a very similar aspect. Our optimization target were on the design of the component, design of the e-motors, and optimization at the overall vehicle. So here, how to tailor the different components for a specific vehicle, and in order to have here an optimization at this aspect. Yes.
Mm-hmm. Mikael?
Yes, I can comment at this,
Yes.
this point of view. I may disagree a little bit, by the way. Of course, life is a compromise. If you are saying that you want to reduce dysprosium, I agree 300% because this
Speak closer to the mic.
Just eat it.
yes, I'm just saying, if you want to reduce dysprosium, I agree 300% because dysprosium is in one single country. But if you want to reduce very much neodymium, increasing the copper, wait a moment. Copper is as much critical. So life is a compromise. You have to say, where are you going? The best is not reducing or cutting completely rare earth. The best is having the right compromise, reducing the copper, because copper is becoming as much critical as neodymium, remember. Okay, so trying to reduce at 100% neodymium, I don't think it is the right choice. Okay?
Yeah, good.
Well, we can always recycle it.
Yes.
Yeah, good.
Marco, please state your name and affiliation.
So my name is Marco Tella. I am from Extreme Engineering, a newly born company for providing consultancy on electromobility. Well, the question is, I'm very curious about the last project, and because you mentioned something that is unusual, the DC-DC converter in between the battery and. But you also mentioned a figure for the efficiency, which is quite remarkable, 99%. So this efficiency is including also the DC converter, first question. Second question, you showed us the inverter, something very innovative on the inverter, but you didn't show us anything about the DC-DC converter. Why?
So the 99% figure, and in general all the efficiency figure that I presented in the slides refer to single components. So for the overall Eaxle, the figure to be taken into account is the distance-specific energy consumption that we measured and then mentioned at the end, 127 watt-hour per kilometer. That's what we are trying to minimize at the vehicle level for the full architecture. Concerning the development of the DC-DC converter, this is an off-the-shelf component. That's why I didn't present anything. We were concentrating our efforts on the inverter and on the motor, while the DC-DC converter is basically something that already exists, and we only developed the control part to enable the super fast charging and to make the DC-DC converter speaking with the control of the engine, of the motor. And did I reply to everything that you asked me? Or
It's not a silicon carbide based.
no, the silicon carbide is the inverter. The DC-DC converter is IGBT.
More questions from the audience. Yes, I know we are the people between you and lunch, but don't. Yeah, sure. Like the coffee this morning.
My name is Ciro Attajanese. I am from ELMO Consortium, Italian Inter-University Consortium on Electrification of Mobility. And congratulations for the presentation. We heard a lot of improvement in terms of performances of e-drives. But from this point of view, do you believe that it's would be necessary to have a common framework to compare the performances? I mean, we heard about efficiency. Efficiency can be evaluated in different ways. Power efficiency, energy efficiency on at low speed, at constant speed, at high speed, on WLTP cycle, and so on. The torque. You can give the value of the torque at the wheel or at the axis of the motor, and so on. I believe that we should try to define a common framework in which we can compare the performances of the solution proposed, because this can help also the final user of the solution. Another question is some project, I don't remember which, uses data cloud for exchanging data between the algorithm of control and the drive. From this point of view, there is some evaluation, some assessment of the vulnerability to cyber attack in this case.
Take the mic.
I would just piggyback on this and add also on energy use on this. I mean, you are supposed to be gaining something, but you're also spending something, and you evaluated it.
Bueno, the project maybe could be aware. We used cloud data to store the information from the diagnosis tool, where then, of course, it could be developed a machine learning-based analysis or something like this, and there should be cybersecurity control on that. But at this moment, what there is restricted. It's a domain, a private domain, that is not included in a project, but it's something that the owner of that data needs to do. It could be an additional part of the project, but the main objective was to provide this data, and then the owner of that data has to provide those security levels. And for the first question, I quite agree. We have had difficulties to define how to quantify that improvements on efficiency. And as you could have seen, there are some values that we are still quantifying, so I totally agree. Just that.
If you allow me just to continue in this direction, so I think the topics of so data privacy, data confidentiality, so cyber attack is a very, very hot topic, especially, so I hope I'm close enough, so especially in terms of capability for exploitation of the result. But I think at the same time, so we have a new scientific direction, and we have a new calls thinking about the data calls, especially addressing this very sensitive aspect as well. So here, so I'm fully convinced on that a convergence in terms of technology and convergence in terms of sciences will be required to support here the the development and later on the deployment, exploitation of this kind of aspect. So this would be here the first part of the question. The second part of the question in terms of providing clear and standardized framework for the evaluation of the outcomes. Fully agree with you. I would even make a step further. So here, the air track, in the different strategical roadmap has already provided some market segment specific. I wanted to say target or direction, aspects which are relevant for this specific target. So here, I think it would be good to be compliant or in line with the market reality. So what are the different market segments? What are the specific aspects to be optimized for the different aspects of market segment, and then to deploy evaluation framework which has been then tailored for the different segments.
Yeah.
I can make a comment on security, if you allow me. I was recently invited to make a presentation at the European and US webinar on cybersecurity, specifically for SMEs. I can say this: if you have a key, 248 RSA key digit, with a classical computer that still does not exist in computational speed, it takes 300 millions to break the key. Okay? 300 millions. Million years. Okay? If you have a specialized quantum computer, which is not faster, but it is specialized specifically for that, it takes 5 hours. So security, contrary to what one reviewer was saying, is not an option. Security is a must for whatever you do, whether it is a bike or whether it is a car. Okay? So you also have to apply a time gate. And if you apply a time gate, you can secure for many years from now also against quantum computer attack. But you need also apply a time gate to your key, because quantum computers will come. And I repeat, they are not faster, but they are specialized specifically for that. So security is a big issue, whatever you're doing.
Yeah, good point.
I can only agree. Quantum computers will come. Neuromorphic computing will come. And this will enable also technologies for efficiency testing. And I agree with Eric that that is really something that we experienced also in Sys2Wheel, where IDIADA is strongly working to develop test procedures for commercial vehicles. So we are looking in the direction mission profile, from a mission profile, so a dedicated vehicle to perform a certain mission should be tested in a certain specific way, and not one vehicle fits all solutions. These are standardized tests. When I talk about this neuromorphic computing, this could be an enabler also for efficiency and development of artificial intelligence-based digital twins that we have on the edges, that we have in the vehicles, that we have in the components. But as Pietro said, computational expensity is then somehow limiting the efficiency gain that we get by this specific models that would enable to operate components close to their limits, and thus again increasing efficiency. So we need at the edges computational technology that enable these computation and the creation of such digital twins at the edges. I mean operational digital twins, getting input from data in the operation phase.
Okay. Any more questions from the audience? If not, maybe maybe Eric made his second. Okay, so then Ian, please. Yeah. So Ian Fire from Bosch.
You saved me the introduction. I would like to completely agree with the comment or question here regarding the framework for comparing results. We've been doing this for 10 years now. Maurizio, I met you back in 2011, I think, or 10, the first time. If I add up all the increase by 5%, by 2%, by 7%, 15%, we must be over about 200, 300% improvements. So I think it's really, really important in the future not to only present the success stories, but also present what didn't work. We can only get better if we also be honest about what didn't work in the project. So, for the record, be honest about your results, present the highlights, but also present the lowlights.
Yeah, good point. Thank you, Ian, for this. Eric, now it's your turn, please.
If you allow me to thank you very much for this comment, and I really love that. If you allow me to react on this, in this context, to present something. So this is always also the temptation to present the highlights, and so this is what I really would like to achieve is not only disseminating the result, but achieving communication and bilateral communication engagement. Really happy to have this more detailed discussion bilaterally. So on this, I think at least for me it would be more easy to describe the downlight as well.
I can agree with this. So I remember one of my professors when I was a student stating a PhD thesis that shows which path has not led to success might be even more worthwhile than a PhD thesis that has shown a success, because that particular thesis will prevent hundreds of others from making the same mistakes. Yeah.
In theory.
In theory, yes. Yeah.
I keep seeing here projects on hybrid supercap and battery.
Yeah.
I haven't seen yet one succeeding, yet I see proposals.
Okay, good. So, yeah, let's maybe, yeah. Pietro, you showed 2 applications, 100 volts and 48 volts. And I heard you mentioning in the beginning something about mild hybrid, but your cars are battery electric vehicles. So how did you come to this mild hybrid statement?
Thank you, Christoph. We agreed a little bit on this before, just to be correct and honest, okay, 100%.
But this mild hybrid statement really triggered me. So what was that about?
When we started this project, I was invited 4 years ago by a large semiconductor company to comment the 3 roadmaps published by Valeo, by Bosch, and by Continental. In these 3 roadmaps, they were claiming that by 2025, some 25 to 30% of the market was 48-volt hybrid, mild hybrid. So this company was asking me, do we have to invest here or not? I made a presentation on 150 pages, but was all rubbish. The only final comment was rubbish. These roadmaps are all wrong because you can produce the inverter, you can produce the motor, but they are not looking at the overall system. And one of my partners told me, Pietro, you don't understand the business. I say, I don't understand the business, but I want to try to understand the system. And I believe that these 3 roadmaps are all wrong. After 3 years, the top management of this company called me and said, Pietro, we are closing all our activities on the 48-volt mild hybrids because no one is asking us this from the OEM. And he apologized with me. He said, we lost a lot of money, but now our activities on the 48-volt are closed, totally closed. We will work with you in the 48-volt only for smaller powers, as you are doing. See?
Yeah.
That's the point. So the 48-volt is very critical because, I repeat, you can produce the inverter, you can produce the motor, no problem. But the problem is in the C of the battery that you don't have. You see? So yeah, if you look at the system level, you cannot provide a reliable system for cars in this sense. So at the system level, it doesn't work. Okay? And in fact, nobody is asking this. But also there are other reasons. But these 3 roadmaps were all converging. By 2025, we will have 25 to 30%. So I was criticized a lot by many, not saying that you don't understand the market, but I understand the system. It's different. Okay.
But coming back to your 48 volts, so you're obviously running them in your light vehicle.
Yes, but we
limited to something like 24.
First, we limit the power.
Yes.
Because and then we also choose specific batteries working in a specific way.
Yeah.
And then we limit the speed.
Yeah.
Because increasing the speed, you have to increase very much the power, and then you destroy the battery. Yeah. Because the real point is the battery, it's not the motor or the inverter. Okay. So we use it 4-wheel drive, not a single motor or thing, 4-wheel drive because we don't want to cool anything, and then it has a choice, and that's why Valeo is looking at what we are doing in the N1 vehicle with 4-wheel drive with this technology. Okay.
Yeah. Yeah.
But forget higher speed and forget
sure.
mild hybrid with a larger. And by the way, our cars are also lighter.
Yes.
Which helps very much. But if you are addressing heavier cars or higher speed, forget it.
Yeah. Good. What is then the voltage of the rest of your system behind the motors? So battery, DC-DC, and all that kind of stuff.
No, we do not have DC-DC. We have motor, inverter. That's a battery, inverter, motor.
Okay.
If you introduce one extra element, so I take 1 more minute, okay, if you don't mind.
Yeah, yeah.
2008, ST Microelectronics and Infineon presented their roadmaps on silicon MOSFET. I was at Centro Ricerche Fiat. I said, okay, urban mobility is there, 100 volt. I was criticized a lot because now people are going to much higher voltage because you cannot control the control if you stay at this voltage. Now, look at what's going on in Korea. Look at what's going on in China. I have the fortune to have a specific collaboration with Cattle and with LG. If you look at what they are addressing in their roadmap for city drive, 100 volt, tap, chapali, we say in Italian. Today, in their roadmap, city mobility is 100 volt because it's silicon MOSFET. It's cheap, tremendously efficient. That's 100 volt. In their roadmap, they're saying, we are developing most of our battery pack for people asking 100 volt today because of the efficiency.
Okay.
Okay. City mobility.
Okay, thank you. I think there was Marco raising his hand for a question. It's already completed? Okay. Eric?
So Bernard from Sister Wheel. So here you have TT Tech onboarded there. So a very fast-growing company, so strongly innovative, and they have introduced a TSN. So do you have any further information about the TTPC introduced by TT Tech in the aerospace domain versus a TSN automotive domain? Is it related to the communication over the power line, or what?
Yeah, it's related to the communication of the power line, but I cannot give more information on this. Sorry for us for that.
But I think this power line communication is something that many of us have at our homes, yeah? So between the router and your laptops and so
Yes,
forth.
but not with that technology.
Yeah, okay. Good. So we have still like 10 minutes left, and there's no lunch before 13:05. So where are your questions?
It's fine, we can start the lunch at 1.
Eric, yes. Well, let me start with one question to you. How are you going to demonstrate your 1,000 kilometers?
Do you mean which
EVC
road?
1000.
You mean which road, or?
How does the project demonstrate going the 1,000 kilometers with a limited time for charging?
Yeah, so here we have defined a specific road around Theo Ilmenau, so who do have a specific design of the road, so where this experiment will be performed accordingly.
Okay.
So we had the limitation in terms of homologation that our original plan was to go over the countries and to have a trip from Brussels to Ingolstadt. So we had to revise this plan due to homologation limited to one specific country, and then to go for a public road which is closer to the infrastructure in order to act as mitigation measures in case we should have any problem which are not expected. But this will be here dedicated circuit public road around Theo Ilmenau to go through this.
Okay. Thank you. Now your question.
Okay, I would like to revert a little bit the situation. So here you have seen different program, different technology. So from your point of view, so we have a very large audience. What would be here your specific wishes, needs, link to your activities, being a more research activity, being more industrialization? What would be here the pinpoint you have identified during the presentation? Question to the audience.
Which is always a difficult one. Should I select one volunteer? I
cannot stay silent for this. In 2010, we had a meeting at the European Commission, and I took the freedom to take my computer. I took the freedom to show my computer. My laptop was a Macintosh, and I said, I don't see the charger. Can you help me to understand where the charger is? And they said, but my first Apple had the charger on board. My first PC had the charger on board. I do not see any charger here. And then I was contested. I was even considered by one Italian, one German company, a criminal, because I was saying that we didn't need any on-board charger at the time. Some of you were present at that, okay? And I am very happy to listen to the European Commission that finally, after Tesla, this year, has presented a small charger, DC charger, for all these customers. Now, also in Europe, we are understanding that AC charger on board are no sense. Are no sense. I repeat what I said 10 years ago. And finally, the European Commission is understanding, pushing somehow, I understood, towards DC charger at low power at home, not AC, because they are more efficient, And like any computer, you don't need a charger in every computer. You have a charger, your wife has the same charger, and it's a DC charger. But if you have an AC, you need a charger in every car. And then I was contested very much at the time. So the DC charger cost a lot of money, and we don't want to copy Tesla. At that time, Tesla was the only one proposing DC charger in high power, no? And now they are proposing DC charger at low power, and everybody is let's say disturbed because they are also doing this. But the discussion started at the European Commission. Some of you were present, I remember, more than 10 years ago, 12 years ago, to be honest.
If I may, I would bridge the two questions because I think it's. I mean, a lot of the solutions are on one side, but the topic was intended to optimize both sides, and unfortunately, I haven't seen much on this interface. So you demonstrate that on that thing, but what you've done is mostly in several projects is increasing the efficiency, which of course increases the range. But to achieve this optimal compromise between the battery size, I mean, if you take a huge battery and then you improve the efficiency, okay, you improve that situation. But I miss the part where we try to also keep the battery to an acceptable size, because we are not using that size, that big size, if we have it, except a few times a year. So I think the part on the charging, and we are stressing that in the future proposals even more, it's important, because I think when you have such high efficiency on the powertrain, we are on the Pareto limit. While this area, I think, needs to be looked at to optimize resources and efficiencies and so on. Also on the charger side, because yes, in some cars those AC charger are quite lousy in terms of efficiency.
And also, if you're operating a charger below the rated power, then the efficiency drops endlessly.
The lousiness was particularly when you're charging at low power, for instance, from the plug at home.
Yeah. Good. So that might be a topic of further research in future programs, indeed. Yeah. Good. Pietro.
Just comment, okay, just before lunch, okay.
Yeah, one remark that I would like to make still is, so we have seen a number of projects here coming also from the Evolve cluster. So there are more of these projects. So Achilles and Sevolver have also been there. So thank you for putting this on display. And so the key access to all these projects would be through the Evolve cluster homepage. And from there you can get to any of the project homepages. So keep these in mind, and Talent Multimobi that we have seen yesterday are also part of that. So up to you now.
I can comment what Maurizio was saying, because this is a long discussion. No? What is the size of the battery? Do we really need a 100 kilowatt hour battery or only 25? This is a long discussion which never stopped. Okay? But there is another point also regarding the efficiency of charging. You have a C rate of the battery, which has a certain value when you charge low, and you have a C value which is higher when you discharge. In Multimobi, we do very simple things. We charge at 1 voltage. When you stop charging, the voltage is automatically set up at a different level, and when you drive, you have another voltage. So we have developed a dynamic battery. We charge at a certain voltage, high voltage. When you stop charging, the voltage is 48 volt. When you start driving, the voltage is 100 volt. It's a dynamic battery. Our patent, by the way.
Yeah, I know OEMs looking at the dual level, so maybe you talk to them or they thought it by themselves.
Yeah, good. Okay. So I'd say if there are no more questions, again, thank you, presenters, for for enduring discussions and questions. Thank you for your patience. And I would like to point out that, please go downstairs and visit the booth of the European Commission to find out more about Horizon Europe, and certainly visit also the partnerships, 2.0, CCAM, batteries, and just where you are standing around and eating. There are also a couple of posters available from the different projects. So please visit these and then enjoy your lunch.